Hello friends, welcome back. Hearty welcome to you. We'll try to solve this problem related to quadratic equations and combination of little arithmetic progressions. This is for 10th grade. A contractor employed 150 workers to complete a job in certain number of days. Due to partly payment of wages, every day 4 more workers start dropping. It took 8 more days to complete the job. In how many days the job was completed? So let's try to understand this. We have been told that a contractor employed 150 workers to complete the job in a certain number of days. So let us assume in this example that the efficiency of each worker is the same. All the workers have same efficiency level, and also it's taken that if you go to the work and you attend there, give your attendance, that means the work is done. Whatever the work you have to do, that work is done. So when the efficiencies are same, it boils down to how many workers are working in both the scenarios. Let's take this. Now what is actually the plan? A contractor employed 150 workers to complete a job in a certain number of days. So I'll write down 150 workers. So contractor employed them and he asked them, you have to work for a certain number of days so that the work will be finished. Now what happened? Due to some unforeseen issues, the contractor was unable to pay their daily wages. So what happened? Every day 4 more workers are started dropping. That means in the second scenario, actually what happened is on the first day 150 workers reported to work. By the second day 4 of them got dissatisfied and they just said bye bye. So we have 146. And the third day we have 142. So what happened now? Every day the number of workers reporting to the job or working on the activity or the task became less. That means obviously it will take more days now. So that number of days we have to find out. So what we will say? We will say that these days are X. So what we are saying? If the contractor employed 150 workers, but since he was unable to pay the wages, so every day 4 were reducing. On the first day 150 turned out, second day 146, third day 142. Like that, for in X days the work is completed. Now I have to find out that X value. Okay, fine. Now, what the first line says, a contractor employed 150 workers to complete a job in certain number of days, and due to this partly payment of wages, the work took the job completion time became 8 days more. So I can go back and say the plan was to finish the work in X minus 8 days, but due to the workers dropping every day, it took X days. So if you are able to understand this, then we are pretty good to start and go ahead. So in this scenario where the efficiency of each worker is the same, it depends on equating the work done in both the scenarios. We generally equate the work done, we measure the work done in man days. What is the meaning of man day? Man day means you can have a space between man and days. The work done by a particular person on a particular day, on a day, or you can say work done by a person in a day is called as man day. So if I now, since the work done by them in every day by each person is the same, now it boils down to the first scenario and the second scenario, the number of workers should be the same. Suppose let us say that the activity is a simple activity like painting or something, where you don't need skills and there is no dependency between the activities. We can simply say that okay, 10 workers came, we will finish it in 8 days. Now instead of 10 they are becoming 10, 8, 6, 4. It will take more time. But we know that 10 into 8, 80 workers are coming. In the second scenario also, the workers total should be equal to 80 only. The days will be little bit more, but the workers total number should be same. So can I say if the work is equal, nothing but total number of workers reported, or can I say man days, is equal. So total number of workers every day they reported, we just count sum of them, it should be equal. So what is the meaning of that? It is like this: first day 150 in the first scenario, second day also 150, third day also 150, like that. This continued for x minus 8 days. So the work done by 150 people in x minus 8 days should be equal to the work done by 150 on the first day. Second day it is 146. Third day it is 142. Like that, for how many days the work was completed in x days. So the work done in both the scenarios should be equal. Now you can see that 150 x minus 8 days is nothing but 150 into x minus 8 should be equal to, now what is this 140, 150, 146, 142 up to x days? Nothing but it's an arithmetic progression, because I see that a equal to 150 and the common difference is negative of 4 minus 4, and there are x terms there, so n equal to x, and we know sum of n terms formula in arithmetic progression. Sn is given by n by 2 into 2a plus n minus 1 into d. So we know the Sn formula, we can just go ahead and substitute that. We equate both of them, then we will get a quadratic equation, we'll solve it, we'll get the value of x. So let's move forward to the next step. 150 into x minus 8, 150 into x minus 8 equal to, so 150 x minus 8, you know continuous addition is nothing but multiplication, so I can go ahead and write it. Here I have a arithmetic progression as we discussed earlier. So what is the formula for sum of n terms of an arithmetic progression? N by 2, n is here x by 2 into 2 into a is 150, so 2 into 150 plus n minus 1, that's nothing but x minus 1 into d is nothing but minus 4, because every day 4 workers are dropping. So this is our equation which we have to solve. We will get our answer. So the next step will be, we'll just try to simplify this. Take this 2 to here. I will write it as 300 into x minus 8 equal to x into, I will simplify this. 2 into 3, 150 is 300. 300 minus of minus 4 is plus 4. So can I say 304? X into minus 4 is minus 4x. So can I say 300 into x minus 8 equal to x into 304 minus 4x. I think I can take 4 common here, so I'll write down one more step. I will say 300 into x minus 8 equal to, if I take 4 out, I will have 4x into 4 will go 76 times and 4 will go x times. Now this 4 I can cancel here and make it as 75. So my last statement will be 75 into x minus 8 equal to x into 76 minus x, which will give us the quadratic equation, for which we'll find out the roots now. So let's move forward. If you simplify this, I will have 75x minus 75 into 8 is 600 equal to x into 76 is 76x minus x into x is x square. Now get everything to one side, you will see that it's nothing but x square minus x minus 600 equal to 0, and this is nothing but equal to x minus 25 into x plus 24 equal to 0. Now I'll give you a small tip. Whenever the sum is very small value, almost like that means both the roots or zeros are almost equal, take the product and try to find out its square root. Square root of 600 is something in 24 point something. So immediately I know the value should be 24 and 25. So you can always leverage that. Whenever the sum or basically the difference between two numbers is very small, then you can take a square root of the product and that will help you to find out the value. So x equal to 25. That means the number of days that took to complete the job is nothing but 25. Now let's verify this. 75 into x minus 8, that is 17, should be equal to x is 25 into 76 minus 25, 51. Let's multiply this. 75 into 17, 17 70s are 1190 plus 85, 1275. 25 into 51 is also 1275. So we have both of them are same. So that's the solution for this problem. So let me summarize this before we wind this up. A contractor employed 150 workers to complete a job in certain number of days. Due to partly payment of wages every day, 4 more workers start dropping. It took 8 more days to complete the job. In how many days the job was completed? We started with saying, let us say it took x days to complete the job. So the planned execution time was x minus 8 days, and as per the plan, according to contractor, every day 150 workers should report to the work for x minus 8 days so that they can finish the job. But due to unfortunate situation, he was unable to pay the daily wages for them completely. Partly payment, he was doing only part payment, so they got dissatisfied and they just dropped out from the work. So how we are just taking liberty here and saying that every day 4 more workers are dropping, so that will create one arithmetic progression there. So in this scenario where the efficiency of each worker is same, we just calculate how many workers reported in both the scenario. Total number of workers reported in both the scenarios is equal. That's nothing but work done in both the scenarios is equal. So you get a quadratic equation, we solve it, we get x equal to 25. That means the total number of days, the number of days that took to finish the work in the actual scenario when workers were not coming every day 150 but they are dropping for day by day. So I'll catch you once again with another interesting example. Thanks for your time and support. Bye for now.